Okay. Now I clean up my messy code and it's time to explain it to you. We start execution from main. Okay, we start execution from main, and the first line means R1 equals to address of variable m. That's the meaning of LDR. R1, comma, equal sign m. And the next is R1 equals to memory of R1. What does it mean? It means memory of the address of M. Okay, so look at R1 as address of M. That means our variable M is located here. M. Can you see that? Variable M. So it's located at some floor number. Floor number 0x ... Okay? I don't care the exact number. What I care is it's way up in the sky because this condominium is so tall. How tall? How many floors? Up to here? To the 32 floors. 4 billion floors. Okay? 4 billion floors up in the sky. Alright? And this floor number is so tall. I don't care the exact number. What I care is it's located somewhere. So you need an elevator to go up there and get the value out. Okay? The next line, LDR R2 POINTR. So this line means R2 equals to what? Equals to the address of num. Not good. Let me address of num. Why? Why do I know that POINTR contains the address of num? Because when we declare pointer here, POINTR, it is initialized to num. That's the meaning. Okay? That's the meaning of address of num. Alright. Next, move R0, 0. That means R0 equals 0. Okay, I put on the left hand side. Next is called loop. is just a label name. Okay? Not a function name. It's just a label name. Okay? And the meaning of this is R3 equals to R2. Okay? And R2 equals to R2 plus 4. There are two sub-operations inside. There are two sub-operations. Okay? What is R2? R2 is the memory of R2 is the address of num. Okay? R2 is the address of num. Remember? Then add R0, R0, R3. What does it mean? Oops, I'm sorry, I skipped some details. R3 equals to memory of R2, sorry. Please fix this. R3 equals to memory of R2, which is memory of num. Memory of address of num. Okay? Please fix this. Where is num? Where is num? Num is here, right? The fourth line. So, the first line is sum. So, sum is somewhere here. The second line is m. The third line is num. Right? So, num contains 3, 5, 7, 9. Up in 3, 5, 7, 9. It's an array. Okay? Num is an array. Okay? That means R3 now contains 3. Okay? 3, 5, 7, 9. R3 now contains 3. And R0, let me use the left hand side. R0 equals to R0 plus 3. But R0 is 0. So therefore R0 equals to 0 plus 3. So it becomes 3 now. Right? Then sub R1 with 1. What does it mean? It means R1 equals to R1 subtract 1. What is the value of R1? Hello? What is the value of R1? R1 is, yes. So R1 becomes 4 at this location. R1 is 4 because M is initialized to 4. So it's going to be 4 subtract 1. Right? So 4 here shows up here. Subtract 1 becomes 3. Then R1 is compare. CMP stand for compare. R1 compare with 0. R1 now is 3. 3 is 0. 3 versus 0. That means 3 is greater than 0. Here, GT. GT means greater than, remember? 3 greater than 0. The answer is true or false? True. That means when it's true, you jump back to this way, to loop, when it is true. You jump to loop location if it's true, and the whole thing repeats again. Okay? The whole thing repeats again until R3, until R1 becomes what? Becomes 0. See that? R1 is subtracted by 1 again and again and again until R1 becomes 0. What happened when R1 becomes 0? GT is false, right? GT is false and no jump, continue. Okay? No jumping back to the loop. Just continue the next instruction. Okay? Continue. All the way to the last instruction, BXLR. And main will finish its execution. Okay, I think I'm gonna stop here.